a process model, a dynamic process model. Okay, based on the theoretical models that we can do na lang. Ang nagagawa lang natin is theoretical model. We cannot do empirical models kasi wala tayo sa planta. Okay? So, sa subject ko, kailangan nyo rin mag-install ng MATLAB soon kasi we will be examining kung tama ba yung models natin by inputting our transfer function sa MATLAB later on. Okay? So, why do we need to learn dynamic process models? So, my topic, okay, this lecture is based on Seborg, Chapter 2, the theoretical models. Okay? So, first there is yung sinabi dun sa Chapter 2 ni Seborg ay kung bakit ba inaaral natin ang process models or why do we need to develop process models. Una, what is a model? Ano muna yung model? What is model? Any idea? Any idea what is a model? Lagi na natin binabanggit yan. Hindi lang sa subject ko. Binabanggit din natin yan sa mga ibang subjects. Okay. So in terms of process control, okay, model is a representation or we say mathematical representation of a process considering the conservation laws. Okay, it might be example of the conservation laws. We have material balances. So this is law of conservation of mass. We have energy balance, energy conservation. And we also use the component balance. Okay, we have component balance. So all of these equation, okay, these equations, ang gusto nating mangyari is merge them into one single equation that can represent a process. Okay, why do we need to model? Why do we need to have a mathematical model of the process? Para, in order for us to improve our understanding of the process behavior and performance. Okay? Sabi ko sa inyo, ang process before you can design a control system, you need to understand the process. So, one way of understanding or improving your understanding sa process behavior is to develop a mathematical model. Okay? By that, parang iniisa-isa mo, kinukuto mo yung process, kung ano ba yung mga kailangan mong i-anticipate to control it. Okay? Dynamic process models are also used to train operating personnel sa industry kasi they can be able to see the overview of the process when you create a mathematical model. Sa mathematical model, we represent there the variables, the manipulating variables, the disturbances, and operating parameters, process parameters, ganun. Sa model na yun, nakikita na doon. So, kapag meron kang mathematical model, it's easier to train operating personnel. So, it will enable us also to evaluate control strategies. Okay. So, kapag meron kang mathematical model, you can evaluate kung ano yung magiging output. Okay, by changing some inputs, you can actually see outputs diretso. Okay, but it is a theoretical output din since you develop your mathematical model through theoretical uh, data. Okay, but theoretical data with theoretical outputs parang malapit naman sa real happening. Okay? So we can interfere with economic models to optimize the operation. Okay. So we will have an illustrative example here. So babalikan natin yung example natin na blending process. Okay, how to model that process, anticipating the dynamics of the process. Kasi sa ating introduction, more on steady state ang ginawa natin doon. Now, we deal with dynamics. We deal with change over time. So, we have the concentration, density, time, height. Okay. We deal with change in time. Hindi na siya equal to zero. Kasi unsteady state na ang aaralin natin. Okay. So, I will introduce to you the steps in developing a process model, and we will have notations that we will use throughout this subject. Okay. There are three main types of process models. Una yung theoretical model na sinasabi ko, empirical model, and semi-empirical models. So we have a theoretical model. Ang ibig sabihin ng theoretical model, yun yung parang ginagawa natin kahit nakaupo lang tayo. Okay? Kahit anticipating, of course, dapat may alam tayo sa process kahit nakaupo lang tayo. What I mean here is it does not include yung totoong process. Okay? It's more on theories. So, ang advantages nito, of course, it is based on process physics and chemistry, and we can extrapolate well. Ang disadvantage naman nito is expensive and difficult to develop. Kailangan ng talagang control engineer, kailangan ng isang expert sa design. Yan ang disadvantage and may require unknown parameters. Empirical models, on the other hand, it is easy to develop pero hindi ka makaka-extrapolate. Well, you are just limited to that process and you are limited by the cost that you're going to spend. Kasi kung nasa planta ka, pwede ka makadevelop ng empirical model but magsasayang ka ng mga chemicals. Ganun. Okay, so more on trial and error itong empirical model. Okay, wala naman tayo sa planta, so it is impossible for us to develop an empirical model. Next, we have a semi-empirical model. So, same setup sa empirical model. Kailangan nasa planta ka. So, our focus for today's lecture is more about theoretical models. Okay? So, here are the steps in developing a model. So, here are the modeling steps. First, we need to determine the objective and end use of the model. So, determine the required level of detail or model accuracy. Sa step 1 na to, okay, kailangan mong specify kung ano yung control objective mo. Okay, for example, dun sa unang example natin na reactor, right? Ang control objective natin dun is to control the temperature. Okay? You need that. You need that data para malaman mo kung ano yung ilalagay mo at gagamitin mong conservation laws. Okay? Pangalawa, you need to draw a schematic and label the process variables. So, most likely, na-ready na to dati. Schematic. Number 3, this is important din. We need to list our assumptions. Okay? So, simply to extend the modeling objectives. Okay? If it's still met or not. Of course, you need to limit your assumptions. It must be based on, of course, your control objective. Okay, paano kung ang hinahanap mo or your control objective is to control the temperature of the reactor, pero yung assumption mo is constant temperature, yan. So that's not valid. That is not a valid assumption. Okay. Fourth step is, are spatial variations important? So example nun ay concentration, thermal gradients. So may concentration gradient ba siya? May thermal gradient ba? Okay. Most likely, ang mga nasa process naman is continuously steered or constant ang steering. So, most likely, ang spatial variations natin, like your concentration, ay hindi siya nagmamatter kasi ina-assume natin that tank is perfectly mixed. Pati ang temperature, the thermal gradient, so if we are to steer the reactor, pare-pareho ang temperature ng lahat ng points, ng sides of the reactor. Fifth, we need to write the conservation equations that is only applicable sa ating control objective. So for example, yung control objective natin is just to control the flow rates, the concentration. Ganun. So kailangan lang natin ng overall material balance and component balance. Hindi natin kailangan ng energy balance doon because our control objective does not include temperature. Okay? 6, we need introduce rate, equilibrium, or other algebraic relationships kung kinakailangan. Hindi lagi na meron. Kung may reaction na nangyayari, of course, you introduce rates. You introduce algebraic relationships between the components. And then number 7 is perform a DOF analysis. DOF analysis, this is degree of freedom analysis. So, bakit kailangan ito? Kailangan mag-perform ng degree of freedom analysis para malaman kung solvable ba. Okay? We need to know kung solvable ba. Kung wala kasing degree of freedom analysis, tapos solve ka ng solve, tapos magdamag ka na nagsosolve, wala pa ring solution, there might be something wrong. So, before you solve, kailangan may mag-degree of freedom analysis ka muna. Okay? And then number 8, okay, simplify and arrange so that outputs on the left-hand side of the equations, simplify and arrange so that outputs are on the left-hand side of the equation. So this is important when you facilitate programming, okay, when you develop this or input this in a simulation software. 9 is classify inputs as disturbance variable or manipulated variable. Okay. So let's have this example. We already had this blending example. We will revisit this. Okay. So sa dati nating example, yung output stream ay overflow, right? So dito siya lumalabas dati. So medyo ibahin natin. Okay? Ang overflow, hindi na siya overflow kundi lumalabas na siya sa bottom. Okay? Malabas na siya sa bottom. So, ano yung first step natin to develop a process model? First, anong level of detail ang kailangan natin? So, ang gusto lang natin malaman dito is we want to know how X might change with time. So, tayo nagsiset kung gaano kataas, what level of detail we need to know. It is depending on our control objective. So, control objective is we want to know the value of X with a change in time. So, kung nagbabago every second ba, every minute, ang value ng X natin. Okay? Next na step is draw and label schematic, which is already done for us. Third, we enumerate assumptions. Okay? Assumptions, first is no chemical transformation. So, wala daw reaction. There is no reaction going on, so there is no chemicals that were produced from reaction. Kasi walang reaction. Second assumption is that the tank is perfectly mixed. So wala tayong spatial gradients. Okay? Wala tayong concentration gradients. We don't have any thermal gradients. Ayan. So, are spatial variations important? No. Okay, we'll have to see the assumption about. So, since perfectly mixed naman, okay, so, okay itong step 4. Step 5, what are the conservation laws that we need here? Just to control X here, just to know just to know how X might change with time. So we will need unsteady state total mass balance and unsteady state component A mass balance. So wala tayong energy balance dito. We don't have the energy conservation because wala namang temperature. Okay? Sa control objective natin, gusto lang natin malaman kung paano daw magbago ang X with time. Walang sinabi tungkol sa temperature. So, ang equations lang natin ay itong dalawang ito. Okay? Any other required relationships? Dito, wala naman. Okay? Step 7, kailangan nating mag-perform ng degree of freedom analysis to know if this is solvable. So, paano yan? So, let's have the degree of freedom analysis. So, ano muna to? The degree of freedom analysis ensures that the model is solvable. Okay. So, the number of unknowns must be equal to the number of independent model equations. So, ilan yung model equation natin kanina? We only have 2. So, ang gusto natin dapat is equal daw. Okay? Equal ang unknown sa number ng model equations. So, we have this formula. NF is equal to NV minus NE. Okay? NF, this is the number of freedom. V, number of variables. And NE, this is number of model equations. So, there are 3 cases here sa freedom, degree of freedom. If NF is equal to 0, the model is exactly specified and has at least one solution. So, it may or may not be unique. So, if NF is less than 0, the model is underspecified. Baka may kulang. Okay? May kulang sa given. Okay? So, there are infinite solutions. So, NF variables can be arbitrarily chosen. Okay? So, pwede tayong mag-choose ng choose arbitrarily kapag ganito ang meron. Okay? If NF is greater than 0, the model is overspecified. So there are more equations than variables, so there is no solution. Okay? All right. So sa degree of freedom natin dun sa example, okay. Okay, wag mo na yon. So we want that NF is equal to 0 para we have a solution. Okay? Pero it usually starts with a model where NF is greater than 0. So pwede nating gawa ng paraan kapag mas mataas kasi kapag greater than 0 ang NF natin. Okay? So here's how we do the DOF analysis. First, list all quantities in the model that are known constants or are parameters that can be specified. Number two, count the equations, count the number of equations, the NE, and the remaining unknown variables. Okay, so independent variables like time are not unknown process variables. So third, we calculate for DOF. Then fourth, identify the number of equation output variables that will be determined from the existing equation. And then fifth, we'll have to classify the remaining NF, okay, as either manipulated variable, disturbance variable to use up the remaining DOF. So this is step 9 of the model development. So let's dive into our example. So this is how we do the degree of freedom analysis. So list constant parameters. So ano yung mga constant natin dito sa ating equations? We have two equations from total mass balance and component balance. So we can have density as constant. So density is constant daw. So baka isang kind of fluid lang meron dito. So density is all throughout. Okay, so we can have density constant. So this is a new assumption. Okay, count the equations and the remaining process variables. So we have two equations, the total mass balance and the component A balance. We have 7 variables. 7 variables, we have volume, we have flow rate 1. This is coming in to our system. Flow rate 2, we have the overall flow rate. We have our x1, x2, and x. So we have to calculate the degree of freedom, and degree of freedom is equal to 5. Okay. So fourth step is output variables. So dalawa lang ang output variables dapat natin. Kasi dalawa lang ang equation natin. Okay? So hindi natin masosolve yan kung gawin nating mas mataas or mas mababa ang output variables. Okay? Kapag titingnan ninyo, ang output variables or ang output variables natin, we have 3. Right? We have 3. Okay? Pero sa ating degree of freedom analysis for this blending process, dalawa ang kinonsider natin. We have volume and the overall the output concentration X. Ang isang W natin, we included it as an input variable. Bakit? So we can choose, ito tinanong ko din to nung inaaral ko. Bakit ang output variable naging input variable? So I searched for it, and then meron din pala sa Seborg. May sinabi si Seborg doon. So ito, sabi niya, note that physical output effluent flow rate W is classified as a mathematical input. Output siya. Because it can be specified arbitrarily. Anong ibig sabihin ng arbitrarily? Anong ibig sabihin ng arbitrarily? With no specific reason. So parang pinili lang niya or pinili lang ni Seborg ang W as a mathematical input for no specific reason. Pero ang iniisip ko, this is chosen as an input variable instead of output variable. Kasi kapag tatlo na kasi itong output variable natin, tas dadalawa lang itong equation natin, this can be considered as non-solvable. Hindi siya masosolve. So, pwede rin na ang rason na pwede siyang maging input variable kasi say pwede nating baguhin ang flow rate ng output natin dito. Pwede nating baguhin, right? Pag binago natin ito, it can be a result of another a value of W. Okay? Kung pare-pareho ang pumapasok dito sa dalawang to, tapos inipit mo itong last, inipit mo itong paglabasan niya, so the concentration here might change and the volume here changes din. So if the result of our action that we manipulate W here, it can bring out another value of W. Okay, so it can be considered as input variable. Okay, kasi it is manipulated. We can manipulate it. So input variables are either manipulated or disturbance, right? So yun ang theory ko, which also makes sense naman. Ang sabi naman ni Seborg dito, it is chosen arbitrarily. So it can be for the reason to just to simplify process models. Ito yung pangit sa theoretical modeling. So we need to have an arbitrary assumption minsan. Okay? We choose arbitrarily among the variables just to simplify the modeling steps. You know? Okay? So for this, since 5 ang ating degree of freedom and gusto natin dapat is 0, right? So kailangan 0 siya. So ang output variable natin na kinonsider is dalawa din kasi dalawa ang ating NE, right? Dalawa. So dapat dalawa din ang NV natin para ang NF natin is equal to 0. Now, ang calculated DOF natin is 5. So we can have the remaining input variables, yung remaining input variables na 5, okay, ay gagawin nating, i-assign natin as manipulated variable and disturbance. So kung manipulated variable, it can help us control our control objective. Disturbance, we assign this as something that can disturb our process. Okay, so this makes it solvable. Pwede nang isolve. Okay? Gets ba? Any question about that? May naguluhan ba? Guys, may naguluhan?
Sir, pag dalawa yung number of equation and ganoon din yung number
Yes?
ng output variable, sir.
Medyo mahina ang boses. Sino yan?
Sir, tanong ko lang po, sir. Kapag nakadepende po ba yung output variable na number ng output variable sa equation, sir? Sa number ng equation or hindi?
Yes. Depende yan. So kung una kasi nating malalaman kung ilan ang model equations, okay, ang involved sa ating process modeling. Sa example natin, dalawa. Okay, so we aim for NF is equal to 0, right? Ang formula for NF is equal to NE minus NV, right? Ang NE natin, malalaman natin mas maaga kaysa sa NV, right? Ang alam natin dito is dalawa. Okay, so para maging 0 tong NF, kailangan ang NV natin ay dalawa din. Okay, so dito dalawa. Okay, did I answer your question?
Yes, sir. Thank you, sir.
Okay, may tanong pa? Okay, so let's proceed since nalaman na natin na solvable ang ating blending process. Yun lang ang dahilan na mag-degree of freedom tayo para malaman kung solvable. Okay, so it is solvable. Alright. So meron tayo, so that is step 7. Step 7 yung degree of freedom analysis. Step 8 naman tayo. Step 8, we simplify the model. So simplify in which we input our new assumptions din, which is our new assumption is density is constant. Okay. So this equation, it came from total mass balance. Total mass balance, and ito, the rate of accumulation or the change over time is hindi na siya zero because we are dealing with unsteady states. Okay. So ilabas natin tong density since it is constant. So we have only dV over dt is equal to 1 over density times the quantity W1 plus W2 minus W. So we have defined the change in volume with change in time dito. Okay? Next, when we consider the change in change of x with time. Okay? Change of x with time, yun yung isang gusto nating malaman. So how x might change with change in time, ganun. Okay, so we have our component balance. We have this our component balance, and density is constant. So nilabas natin tong density. So we only have dv dx dt. It's equal to W1 x1 plus W2 x2 minus Wx. Alam nyo naman yan. Component balance lang yan. So ito, we expand this by product rule sa inyong DC. So this will be equal to PV dx over dt plus density x dv over dt. So substitute it here. Okay. So we have this main equation again. Okay. So we already have our value for, or we already have the equivalent of dv over dt. So we have a dv over dt here. Okay. We substitute that here. It is a dv over dt. And we can have the final equation, which will be our model equation. Model equation that describes defines our control objective. Ano ulit yung control objective natin? What is our control objective again? Our control objective is we want to know how x might change with time. Tingnan natin kung na-answer yan ng equation natin. So we have dx over dt. So that tells us about the change of x over time. So we have our model equation here. So this is our model equation na. So, yan na yun. Yan na yung answer, guys. May question ba? That is our answer now. Okay, let's have a recap. So, una, okay, we are given a problem. We are given a blending example. Okay, with this schematic diagram. So if we are to look at it, kapag titingnan mo yan, ano ba ang gusto mong malaman? Okay? Ano ba yung gusto mong i-control dyan? Gusto mo ba na malaman kung ano yung value ng x2 kaysa sa value ng x? So ano ba yung pinaka-importante na malaman mo kapag nasa industry ka? Diba? Gusto mo kung anong gusto mong malaman is x, right? Paano kung palitan ang ito? Ano kaya ang value ng x ko? Diba? Ito yung tinatanong natin sa sarili natin. Kapag pinalitan ko tong x2, ano na kaya yung value ng x ko? Ganon. So, this becomes our control objective. This becomes our point of interest. Ano tong x? Okay. Kapag iniba ang value ng x1 ko, magbabago tong x ko. Right? Kapag iniba tong value ng x2, magbabago rin tong x ko. So, ano kaya ang gagawin ko? Okay, so our point of interest becomes this. So, ano ang value ng x? Okay, with change with time. So, this becomes our control objective. Now, mag-enumerate ka na ng assumptions mo. So, inassume natin na walang chemical transformations. So, walang reaction. Inassume natin na ang tank ay mixed. So, kung may pumasok na X1 na ibang concentration ng X1, na mix na siya bago siya pumunta dito sa X. Okay, so may direct na influence tong X kapag nagbago siya with time. Okay? Kung hindi siya perfectly mixed kasi, so X1, the concentration here must be marami dito. Pero sa kabila ay parang kakaunti lang. So, it becomes a gradient. So, parang gradient na siya. So, you need to assume something that can simplify or make sense. Okay? Tapos, tatanungin mong sarili mo kung may gradient pa siya din. Okay? So, wala naman since sinabi mo tank is perfectly mixed. So, ano yung gagamitin ko to solve my problem? Okay? Anong gagamitin kong mga equations na nagre-relate nitong x na gusto kong malaman? Okay? So, we have the total mass balance. So, kung iniba mo kasi ang flow rate nito, may iba din ang concentration ng x natin kasi mas marami pupuntang x1 kapag tinaasan natin ang value ng W1 natin. Ganon din dito kapag taasan natin tong value ng W natin, W2 natin, tataas din ang papasok na x2. So, magbabago ang ating x. Right? So, kailangan talaga itong mass balance. Next, of course, kailangan natin ng component balance na dyan kasi ito yung gusto natin, yung x. Okay? And then, so, ang gusto ko bang malaman ay solvable with the control objective na magbabago ang x with time. Solvable ba siya? Tatanungin mo sarili mo. So, masasagot yan by performing DOF analysis. Okay? And then, doon na natin i-simplify, gamitin na natin ang ating mga equations and maglagay pa tayo ng mga assumptions na kailangan para ma-simplify ang ating model equation with the thought na solvable siya. Okay? Kung hindi siya solvable, wag mo na ituloy. Okay? Alright? May tanong pa? Do you have any question about that? Okay, wala. Okay, so ang step 9 natin pala, may step 9 pa pala, no? So classify as inputs or inputs as disturbance variable or manipulated variable. So ginawa na kasi natin yan sa degree of freedom analysis. So ang MV natin, manipulated variable, So, maglalagay tayo ng valve here. Maglalagay tayo ng valve dito sa W2, ay W2 pala. Maglalagay tayo ng valve sa W2 at dito sa X. So, kapag meron tayong manipulated variable dyan, we can design a control system. Okay. And then we have our disturbance na hindi talaga natin may iwasan. Okay. So ito, we don't have a valve here sa X sa W1. So this can be a disturbance. Okay. So along with its X1, dito rin disturbance na din tong X2. So ang tanong dito, what are other variables that we could have considered para maiba ang ating model equation? Okay, so we have what what are some alternative models that we could have considered? Okay, so first, kapag kinonstant natin ang volume, okay, yung kanina kasi 'di ba hindi natin kinonstant ang volume. So if volume, so if first we have constant volume. So if constant ang volume, dV over dt, this becomes 0. And we could have, kapag 0 ito, we could have equal exit flow and sum of the inlet flow rate. So equal sila. We have W1 plus W2. It's equal to W. So may iba ang ating model equation. Okay? Pwede din natin inassume na overflow ang ginamit sa tank. So hindi siya dito sa baba. Pwede dito din natin na ilagay na kagaya ng example natin sa una. Okay? Pwede din naman na yung tank is close. Naka-close yung tank natin tapos pinuno natin hanggang sa taas ang volume. Okay? So may iba ang ating model equation. Pwede tayong naglagay din ng liquid level control that keeps V essentially constant by adjusting a flow rate. So, maraming ways to or di kaya madaming mabubuong model equation depending on your control objective. Okay? Depending on what you are interested dyan. Okay? Any question? So next meeting we'll have more illustrative examples. Ito na yung what if heated tank na rin to. Okay? What if we have a constant hold up, ganun. Constant volume hold up, ganun. Or variable yung volume. Ganun. Okay, so next meeting we'll have more illustrative examples about this. So ito yung isa is about stir tank heating process. Okay? So for now, i-digest nyo muna yung ito kasi it's a lot. I promise you. Medyo mahirap ang process modeling. Okay? Do you have any question? Okay, so parang 1 hour lang ang ating lecture. Okay. Open niyo ulit camera niyo.
Sir, may tanong lang kami ulit, sir. About
Okay.
sa ano, sir, sa tawag dito. dun sa manipulated, ay, sa sa DV, sir,
Ah,
disturbance variable. Bakit nasali yung
yes.
X? Ba't daw nasali yung X2 dun sa DV, sir? Eh, may valve naman dun sa strip.
Okay. Saan? Okay, balikan natin yan.
Yun sa
Anong
may valve,
slide
sir.
yun?
Yes, sir.
Okay, dito.
Yes, sir.
Alright. Bakit nasali itong x2 as a disturbance variable? Eh, meron naman tayong valve. Okay? Kapag valve yan, ang diretsyo nating nakokontrol lang is your flow rate. Diba? Hindi natin alam kung gaano ba karami itong x2. So it can be considered as disturbance. Gets nyo ba? Kasi 'di ba kapag ka may valve kayo and hindi nyo rin alam kung ano yung value nung pumapasok. So hindi nyo alam ang value nitong x2. Okay? So ang direksyon nyo lang na ma-manipulate is W2, hindi itong x2. So what if at certain period of time we have from 1 to 3 minutes, we have value of x2 is equal to 7.7. So, ang susunod from 3 minutes to 6 minutes, it does not mean ng x2 ay 0.7 din. Okay? Kasi walang specified na value nitong x2. Dun sa una kasi nating example, okay? Yung blending example natin na overflow, ang x2 natin ay equal to 1. 'Di ba? So it becomes hindi siya disturbance kasi alam natin ang value nito. Kung pure ito, so we can use that. It can be a manipulated variable to change the concentration inside the tank. Pero kung hindi natin alam ang value nitong x2, hindi mo alam kung tataasan niya ba or bababaan niya yung concentration dito sa tank natin. Gets ba? So it is a disturbance. Regardless na meron siyang control valve. Okay? So ang manipulate lang natin dyan is yung W2, the flow rate, hindi yung concentration. Gets? Na-gets ba?
Yes, sir.
Thank you, sir.
Okay. Okay, may tanong pa?
Wala na po, sir.
Okay. So, sa F2F class natin later on ay magsa-simulate tayo, ha? So, dapat alam nyo na rin mag-Laplace. Okay? Kailangan din natin kasi i-Laplace kasi ang language ng ating MATLAB is in terms of frequency. So, convert natin ang ating mga mathematical equations into Laplace transforms. Okay, so that we can input it in a transfer function. Okay, and then makikita natin ang ating output. Okay, kung wala kayong MATLAB, pwede yung hingin sa mga classmates niyo ang installer. May binigay ako nung third year sila. Okay?
Sir,
Yes.
sir, wala na po kasing copy yung MATLAB sa amin, sir. Pwede po ba namin kunin sa'yo, sir?
Sige, sige. Sa F2F na lang din natin.
Yes, sir. Thank you po.
Okay. Any other questions about sa degree of freedom analysis? Yes.
Sir, may question po ako sa schedule po natin sa face-to-face po. Sir, gagaya din po yung sa set A po na igagawing Thursday din po ulit or mag-stay po na Tuesday laga pa po?
Sa 4B, Tuesday tayo, ngayong time. Ang F2F natin.
Nung last po kasi na meeting natin, sir, sabi mo po isabay na lang po tayo sa set A po. Ganun pa rin po ba ay sa next F2F po or hindi na po?
Hindi ata kaya kasi may mga ibang estudyante doon na may subject sa time na yun or sa time nyo ganun. So mahirap siya i-plot, mahirap siya i-overlap sa isa't isa. So ang gagawin natin ay kung ano yung time natin for F2F, yun din ang F2F time natin. Ang time nila na F2F, yun din sa kanila. So exclusive na. Okay?
Okay po, sir. Thank you po.
Okay. Question pa? Devon, may question ka? Ikaw, Gemma. Gets nyo na ha? Pa-quiz ako sa F2F natin. Si Abagat. Gets? Okay, open nyo ang camera nyo.
Ay, sir, may tanong po pa ako ulit po. Kasi may last subject po kami ng hanggang 1:30 po na online class. Pwede po ba kami malate po kahit onti po sa face-to-face po ng Tuesday?
May ganun ba? Patingin nga, tingnan ko nga yung schedule niya. Sino? Plot ng schedule niyo, ba't ganun? Fourth year B. Let me check. Check for B. Hala, oo nga. May MOR kayo. Sige, pwede siguro kayong malate ng at least 30 minutes. Pwede ba? Kaya yun?
Yes po, sir. Thank you po.
Ayun, sir. Thank you po.
Okay. Pero since MOR yan, baka hindi naman siguro lagi kayong umimit ni Ma'am Jane. So kung ganun, kung hindi kayo umimit ni Ma'am Jane, sabihan niyo ako kung 1:30 tayo or 2 o'clock. Ha?
Sige po, sir.
Okay. Sige. Ano pa? May tanong pa?
Sir, anong coverage ng quiz sa Tuesday next week?
Coverage ng quiz nyo next week ay yung Unit 1, Unit 2, and Unit 3. So, Unit 3 na kasi itong process modeling, di ba? Unit 3 na to. Unit 2 is Laplace transform. So, baka magbigay ako ng problems about Laplace transform. And then, of course, our Unit 1, the terminologies, ganun. And classify kung input invariable, output variable, ganun, manipulated, disturbance, ganun. Okay? And then baka magpa-process model din ako sa inyo. Okay? So, my lecture is based solely sa textbook ni Seborg. So, kung basahin yung buong chapter 2, tingnan nyo yung PowerPoint ko, yun din ang laman. So, pwede yung basahin ulit. Okay? Mas maganda ang explanation ni Seborg. Okay. So, open yung camera nyo at mag-picture tayo. Nagta-travel pa si Lawrence? Ay, hindi na. Nakarating na.
Hindi po.
Yun. Nagtaka lang ako, bakit 18 lang kayo samantala sa Sept A, 38 sila? Ba't kayo sineperate?
Hindi namin alam, sir.
Kayo ba yung mga magagaling? Feel ko kayo yung mga magagaling eh. Okay. Andito na si Queenie. Send ko na lang ulit yung PowerPoint sa inyo para may pagbasehan kayo sa review ninyo. Okay. Thank you for listening. Kung wala ng question, you are dismissed. Bye guys.
Thank you, sir.
Thank you, sir.
Bye.